Hi, I'm Austin, Director of Product Development at Griffin Armament, and we're going to talk about two new products for spring 2025, our enhanced 17.4 bolt carrier and our enhanced gas pocket 17.4 bolt carrier group complete. For a long time in AR-15s, there have been many companies that have tried to improve bolt carrier groups, and essentially these are our attempts to do something in that space. And basically we've taken a number of public domain ideas and also some of our own ideas and put them into a carrier product that we believe to be an improvement of the bolt carrier of the AR-15. And so to work from the outside, initial observations, the standard carrier here that on the table, you can see the key is a longer key than in these two groups. These are allowed to stroke a 1/4 inch further to the rear in your buffer tube if a special buffer is used. That buffer and spring come with the bolt carrier group complete, and you could either shorten your existing buffer or purchase our specific buffer and spring to enable that feature set. We also have a shoulder at the rear of the carrier key, so we have the two 1936 mil-spec screws, and they're installed to the 55 inch-pounds with a thread sealant, and also the mil-spec staking has occurred of the two screws. However, instead of the traditional carrier where we count on the shear strength of the screws to keep the carrier key from migrating rearward and being severed from the carrier, we have a shoulder, a physical shoulder in the bolt carriers that the key rests against. So a little bit stronger design, and the screws have been moved together to allow that shortened carrier key to exist and the extra stroke that it allows to happen. We've also increased the bearing surface of the rails. We've added the gas pocket and moved the gas exhaust ports to the left side of the carrier so that we can reduce peak sound when the rifle is used in conjunction with an NFA registered muzzle suppressor for suppressing the muzzle sound. We have a notch cut out in the front of the carrier that allows the carrier to have a place for gas to go in the event of a case head separation. Those usually occur at the extractor. And so that gas could leave the system instead of being injected into the carrier and bulging and splitting the carrier and splitting the upper receiver. We also have changed the radius of the unlocking part of the bolt cam pin groove in the carrier, so that's been increased so that the moment of rotating the bolt puts less stress on the bolt lugs. We also added an anti-tilt feature at the rear of the carrier that reduces 66% of carrier tilt. And carrier tilt is bad because as the carrier tilts downward, the lugs move upward and they can impact the top of the barrel extension in the receiver, and you get dings on your lugs, and essentially those are stressful incidents that can induce eventual failure of the components. You'll see in the bolt carrier group complete that we've also remapped the carrier to provide an additional 60 thousandths of dwell before the unlocking moment begins. And that's possible by the cam pin groove moving forward 60 thousandths of an inch with respect to where these radii and the ramp are that cause the unlocking to occur. But in the process, you incur a problem. The extractor pin needs to be maintained inside a bore so that the extractor pin doesn't migrate out during operations. So you have a lip on the front of the carrier that's 60 thou longer to enable the extractor pin to stay within the bore. As you see at the forward stroke 60 thou to the rear of this bolt, we have a similar amount of protection of the extractor pin in the mil-spec versus our carrier. So we have a gas nitrided finish with black magnetite deposited on top. That's where we're deriving the 67 Rockwell C hardness of the surface of the carrier. Underneath we have a 43 Rockwell C substrate material and 17.4 stainless steel. And this carrier will take all your mil-spec components to be completed to an operational state. To strip the carrier to show you features of the bolt, I pull the cotter pin, remove the firing pin, remove the cam pin, and we see a multi-diameter, cam pin that essentially allows the hole to be smaller in the bolts, so the webs are stronger. We've also added a band of material around this web because this is a failure point in mil-spec BCGs. Sometimes they, at higher round counts, they shear in half at the cam pin hole. So this keeps the cam pin in a state where it can't be installed backward, and also allows more material to exist at that location. We've added a number of rings to the physical bolt itself. This bolt carrier was designed to be able to be operated with no gas rings, and that functionally successfully happens. However, we found in our testing of the gas pocket feature that the best radiator peak sound reduction occurred with the two gas rings in the rear groove. This is the only place you can put gas rings on this bolt, because the other rings are far enough forward that they stroke outside of the diameter of bore the gas rings are interacting with, and we don't want that to happen. So basically, we also added 30 thou lug radii on the right and left sides of each of the lugs, in place of the near zero radius that is on the mil-spec carrier. Those are like maybe 10 thou radii. Then the mil-spec bolt has a 15 thou radius at the rear of the lug, and we have a 40 thou radius at the rear of the lug. And this makes our geometry natively twice as strong as the mil-spec bolt. We've also added another ejector, so we have a pair of ejectors. We replaced the springs, both extractor and the ejector springs, with 17.7. And the 17.7 has a much higher temperature threshold than the music wire springs used in the mil-spec BCG. And when you're abusing an AR, running it abusively, especially with a sound suppressor, the kind of temperatures that you can incur they seem to create a set in the ejector spring, especially in the mil-spec BCG. And that becomes a source of malfunctions because cases sluggishly eject and they end up hitting the upper receiver and being pushed back into the upper receiver and become stovepipes. So the dual ejectors, they provide a redundant ejector so that if one of the ejectors operates sluggishly, we can still eject the case, as well as the 17.7 springs make that heat set problem essentially go away. We have added the carbon scrapers, which is just kind of a feature that people like to see on the bolts. That feature kind of has its history in the Sterling submachine guns, as well as the FN FAL. I think those are the first firearms to have carbon scraping grooves on the bolts. So basically, you can see that we've, through adding the gas pocket, changing the material to something 20% stronger than C158, using special heat treats like the plasma nitride on the bolt and its black magnetite surface finish, the nickel boron on the carrier key, enabling a longer stroke, enhancing the dwell of the carrier. We've put together a package of features that we feel is one of the most advanced bolt carriers that exists. And it was, I won't really call it a fun project. The parts are really challenging to manufacture, but it's a neat product that I hope you guys will enjoy.